Hello everyone. So today we'll discuss about the Rankine cycle. So basically Rankine cycle is an ideal cycle which is for comparing the performance of steam power plant. It is a modified form of Carnot cycle. So let's start. So basically during the process 1 to 2, it is a heat addition process at constant temperature and pressure. Here the saturated water at point 1, which is isothermally converted into dry saturated steam, which is represented by point 2. So we know that the heat observed during the process 1 to 2 is a latent heat, and during the process 2 to 3 is an isentropic expansion in turbine. Here the pressure falls from P2 to P3, and similarly the temperature falls from P2 to T2 to T3. Here you can see the point 3, which is in between the water saturated line and steam saturated line. So it is in wet steam region. So let's say X3 is a dryness fraction of a steam at point 3, and the process 3 to 4 is a condensation process, and the heat is rejected at constant temperature and constant pressure, and the condensation process is continued until the steam is condensed into water. So you can see in TS diagram the point 4, which is on the saturated water line. It means the heat is rejected by the steam is only latent heat, which is equal to X3 multiply HFG3. And the process 4 to 1 is a pump work. Here the pump which increase the pressure of fluid up to the boiler working pressure. You can see the pressure which is increased from P4 to P1. There is sensible heating or warming of water from point 4 to point 1. So heat observed during the complete cycle, which is equal to the heat observed during the isothermal operation, it means process 1 to 2, and the heat observed during the sensible heating operation from 4 to 1. So heat observed during the isothermal operation 1 to 2 is a latent heat, and the heat absorbed during the process 4 to 1 is a sensible heating process. HFG2 is a latent heat, and HF1 minus HF4 is a sensible heating process. Sensible heat, which is equal to HF1 minus HF4. And these values we can get from the steam tables corresponding to the pressure. So on simplification, we get H2 minus HF3, and heat rejected during the complete cycle, which is equal to the heat rejected during the process 3 to 4, means in condensation process, means that latent heat which is rejected during the process of condensation, which is equal to X3 multiply HFG3, and work done, which is equal to the heat absorbed minus heat rejected. So on simplification we can get H2 minus H3, means the enthalpy at point 2 minus enthalpy at point 3. And for efficiency of Rankine cycle, work done upon heat absorbed, which is equal to H2 minus H3 divided by H2 minus HF3. The point 2 is a dry saturated steam. So from steam table we can directly get the value of Hg2. And point 3 is in wet steam region, so we have to calculate the value of H3, which is equal to HF3 plus X3 multiply HFG3. Suppose if we further superheat the steam from point 2, so we also have to consider the heat addition during the superheating process also. So that is from my side. Thank you. Thanks for watching.